When I'm asked what Landsat 8 has contributed, I'd basically generally identify three broad areas: more data, better data, and new measurements.
The data collection rate that we're experiencing now is almost twice what our original requirements were, which was 400 scenes a day, and we're acquiring anywhere from 700 to 780.
So we're acquiring almost total potential coverage of the sunlit part of the Earth every orbit. That's really phenomenal from the perspective of allowing us to better understand changes. We're now imaging areas we didn't image as well before. Persistently cloudy areas like the tropics and very, very remote high latitude areas, the poles. Those are two of the most changing parts of the Earth. And so our ability to understand some of the most fragile and dynamic parts of this Earth are now being done with Landsat 8.
Another aspect of it is obviously, in terms of the instruments, they're state of the art. Two examples would be what we can do with ice sheets and glaciers now in terms of feature discrimination, feature tracking to estimate ice movement velocities and things of that nature is really critical. And then for darker targets, like water, very dark soils, volcanic rocks, we can even pick up more detail there. So that's really significant, I think, in terms of reaching aspects of the applications community that we couldn't before.
We added a band called the cirrus band that allows us to detect thin clouds and their shadows. And by being able to do that, we are now improving the overall quality of the imagery by removing artifacts that otherwise might have not been detected. We added a coastal aerosol band that gives us the opportunity to better measure constituents in the water column. So that provides new opportunities for the growth of applications in monitoring water quality around the world. We also added an additional thermal band, which has the capability of increasing our understanding of the Earth's energy budget and translating that into important measurements such as evapotranspiration that's important for managing water use. To date, almost all capabilities that we rely on Landsat 8 are working superbly. The operational land imager, OLI, exceeds expectations month after month after month. It's a real testimony to the engineering and the science behind that instrument.
We have seen absolutely no deterioration or degradation of the OLI. Although we did have some early problems with tears, we haven't seen any further degradation there. The way I look at it is the operating constraint is probably going to be the amount of fuel left on the spacecraft.
We've nearly doubled its capacity for imaging, and we're getting those images out to users around the world generally in less than 8 hours. I see nothing but profound success for Landsat 8.
I think at this 5-year point we can look and see that there's been a real revolution in the use of the data because a number of things have kind of come together. We have a high quality spacecraft and instrument. We had the opening of the data policy, which gets the data in a lot more people's hands. Computing is a lot cheaper, storage is a lot cheaper, and the algorithms have gotten to be more sophisticated. So we can really leverage the data that's acquired. I think that we could safely say we are in the business of distributing information, not just data.